From the Library of Congress in Washington, D.C.
Dr. Alex Young from NASA Goddard, and he's going to talk about the total solar eclipse of 2017, and I need say no more. Let's go.
Okay, so thank you for your patience. I apologize for getting stuck in traffic, especially given that I was at NASA headquarters, which is almost walking, well, it is walking distance really. So, and I have visitors from NASA headquarters here, from the Planetary Division, Solar System Exploration. So it's great to see you guys here. So thanks everyone for coming. I tend to, as I said, I tend to move around, so I have to force myself to stay still because they're videotaping, so I'm going to stay right here. But what I'm going to talk about today is something coming up this summer, August 21st, total solar eclipse. And I want to give you some of the perspective from NASA's viewpoint, but you know, all in all, this is not a NASA event. You know, NASA is very used to having their own launches and things that they have control over. This is nature's event, and NASA is just along for the ride. But I want to give you some of the things that are important to NASA and that NASA is really just trying to share to the public. But all in all, this is for everyone. And the good thing is that everyone can experience this in some form or another. Before I go forward, this is what I'd like to do is ask everyone to imagine looking at this blank slide. What do you think about when you think about the sun? You know, on a daily basis, what comes to mind when you think about the sun? So, hot. So maybe something like this, you know, maybe a nice sunrise or a nice sunset. Or maybe even this. It's actually so bright, it's hard to look at. Even if you put a camera up, you don't really see a whole lot. You know, if you're lucky enough to have a telescope, then maybe you'll see something a little more interesting like this. So here you see these objects called sunspots. Just to give you some perspective, these are the size of the Earth or bigger. Okay, so the sun is really, really big. But the only other thing you really get from this is that you can see the sun rotates, which is something we don't really get from our perspective here on the ground. Other than it moves in the sky, we don't actually see that it rotates. But this is actually kind of boring. Okay, this is not too exciting. But what's going to happen on August 21st of this year is that if you're in the right place, you're going to see the sun slowly disappear. Looks like a Pac-Man, for those of us that remember Pac-Man, as the moon moves in front of it. And eventually, you're going to see it completely disappear. And all of a sudden, this is going to be replaced by it. Instead of the bright disk of the sun, the thing that we can't look at with our own eyes, if you're in the right place, and I'll talk more about what I mean by the right place, this is what you see. You see the outer atmosphere of the sun. It's incredibly dynamic. It's wispy, sort of ethereal. You can even see these features at the top that are red. These are things that you can see with your own eyes. And this is the sun that we know really well, especially from space. And it's an opportunity during a total solar eclipse to see the dynamic sun from the ground in a way that we cannot see even with the most sophisticated and amazing technology. Nature gives us a glimpse of this part of the sun that's incredibly dynamic and has huge implications for the science that we're interested in, as well as it actually has implications for even our technological society. And I'll talk a little bit more later about that when I talk about the science specific to the eclipse. But first I want to talk a little bit about what an eclipse is, what makes this eclipse kind of special, and what actually makes eclipses special and rare in general. So one of the things to think about is what's happening here simply is that everything is lined up just right, that the moon moves in front of the sun. It's appears about the same size as the sun in the sky because of its location and its orbit, and it blocks out the disk of the sun. But this doesn't happen all the time. It actually happens during a new moon, and you might think, well, we get a new moon every month, so why doesn't this happen then? Okay, so we're used to thinking about, in the month we have, once a month we see there's a full moon. You see there's also the new moon. So why doesn't this happen all the time? Why don't we get this every month? This is another view of the different phases of the moon's orbit. Just to remind you, so you're sitting on the side of the Earth that's lit up by the sun. Okay? And there's the new moon, the moon that is invisible. You can't see it from the night side. But in the day side, that's actually blocking the sun out during a total solar eclipse. But one of the things that's special is that the orbit of the Earth and the sun make what we call the ecliptic. Okay? But the orbit of the moon around the Earth is actually inclined by about 5 degrees. And so what that means is every time it moves around, it's not always in that plane. Sometimes it's a little bit higher than the plane of the Earth and the sun, and sometimes it's a little bit lower. So this is what you see. Sometimes you get the situation like the top, where it's above the Earth or also below the Earth, and so the shadow that's cast by the sun, by the moon from the sun shining on it, is actually not hitting the Earth. But there's a special time when you actually have that shadow that's cast on the Earth, and that's what's happening during an eclipse. Okay? But there's also one other part of it. Not only is the orbit of the moon inclined, the orbit's actually not a circle. So sometimes it's a little bit farther away from the Earth, sometimes it's a little bit closer. So it has an elliptical orbit, a football sort of shape, or oval. And so I won't go into a lot of detail, but what that actually also means is even when the shadow is lined up just right, there are times when the moon is actually farther from the Earth, and so it actually is not the same size as the sun. It's a little bit smaller than the sun. And so in fact, you get an eclipse, but you get a type of eclipse called an annular eclipse. So you see this ring of fire, people often call it, around the edge of the moon. But we're interested in the case where it's closer and it completely blocks out the sun. That's the total solar eclipse. So that's the special one that we want to see. So what's going to happen on the 21st? So we're looking from behind the moon, and you can see that there's a shadow cast from the moon, and that dark circle is called the Umbra. That's the dark center of the shadow. And if you're in that path where that dark circle travels from starting in Oregon all the way across down to South Carolina, you will see a total solar eclipse. But everyone in North America, Central America, and a portion of South America is going to be in that bigger circle around it. We call that the penumbra, and that's where it's partially blocked. And you'll still see a partial eclipse. So everyone in the United States, North America, Central, and part of South America is going to see at least a partial solar eclipse. And that includes here. So again, here's kind of the series of what you would see. There's the partial eclipse, the moon slowly moving in front of the sun. Just before we get to what we call totality, where the moon is completely blocking out the sun, light will shine through the edges of the moon. So the moon is actually not a nice smooth sphere, but in fact it has mountains and craters. And one of the things that we actually have been able to do with technology from NASA using the LRO spacecraft is actually map out that surface in incredible detail to allow us to see what's going to be cast on the Earth. Because it turns out that it's actually not a simple circle or even an oval, but in fact, it's actually a complicated polygon. So it's crazy. The shadow actually has, sharp edges. Something that when people first simulated it, didn't actually believe it. They thought the computers were lying to them, that they were seeing errors. But in fact, it's because the moon has all this structure around the edge. And so when the sun is shining behind it, light shining through those valleys. And that's what happens right before totality. You get this glimpse of a flash, often called the diamond ring, or even the engagement ring. Sometimes you'll see several of them, which are called Bailey's beads. And that's when the light is shining through the valleys on the moon. So here's another perspective. This is the shadow. So I'm showing you across the country, you're seeing as the shadow, as the umbra is moving, that shows you how the partial eclipse changes across the country. Now, of course, where the partial eclipse disappears, that's right where that black dot is, and that's where all of a sudden you have totality. So it starts at around 10:30 local time in Oregon, travels across the country at about 1,200 to 1,500 miles per hour. It's moving incredibly fast. It gets to South Carolina just close to 3 p.m. local time. And that time period of totality from coast to coast is about an hour and a half. Now the partial phase, seeing partiality, is actually many more hours. So that's going to last for 3 to 4 hours across the whole country. And if you're in that path, if you happen to be in that region we call the path of totality, it's about 70 miles wide, then you have somewhere between 30 seconds if you're on the edge of it, and if you're near the center of it, we call that the center line, it's going to be about 2 to 2.5 minutes roughly. So that's how much totality you get. Okay. And when that happens, this is kind of what you would see from the ground, just looking at the sun. Now, I'll emphasize this a couple of times, and I know many of you have probably heard this many times. You should absolutely never look at the sun with your eyes without the proper protection. This is especially the case for everywhere that there's only a partial eclipse. Okay, so always remember that. The only exception to this is if you are in the path of totality, that brief time period of half a minute to a couple of minutes is the only time you can look at the sun with your naked eyes. Because you're seeing the outer corona, which is 1,000,000 times dimmer than the disk of the sun. The sun itself is so incredibly bright that even when 98 or 99% of it is covered by the moon, it's still too bright to see. Okay, it still can do damage to your eyes. I'll talk a little bit about the ways in which you can look at it safely, but I just want to emphasize that because that's really paramount. Safety is first and foremost. But this is the sequence you would see. This is a sequence, and actually the reason that the sun is kind of reddish is actually that has a filter on it until it gets to totality. And that's when they actually take the filter off. So one of the things that I'll talk about later again is that when you're looking up at the sun during the partial phase, as soon as it gets dark, when you're in the path of totality, that's actually when you take your glasses off. And that's when you're seeing the total solar eclipse. Okay. But what is it really going to look like if I zoom in? Okay, closer in, this is what it's going to look like. But let me tell you a few things about this. So this is a digital image, a photograph. And in fact, our eyes do a better job than this. This does not do it justice in terms of what you see. Now this is zoomed in some. It'll be a bit smaller from your perspective on the ground, but you will see more detail than you can see in here in terms of that wispy structure around the edge. Now, closer to reality, now this is actually taking several images together. It will look more like this. Again, this is zoomed in, but you will see more structure and detail like this because our eyes have much more dynamic range. They can see much more variation in the light, in the fainter light structures that you will see. So here is just a quick, I'm going to talk quickly about the safety aspect again, and then I want to talk a little bit about what's special about this eclipse and put it in perspective with eclipses in general. So a couple of things. So there's two ways to view the partial part of the eclipse. One is to directly look at it, but not with your naked eyes, with glasses specially designed for this. They're usually called safe solar viewing or eclipse viewing glasses. Those are the ones that I've put outside. I brought about 200 pairs, so everybody should at least get one, and we can always help you get more. And there's also lots of them across the country at libraries, community centers. NASA has worked with a lot of other organizations, and we have millions and millions of them out in the public. So there's no shortage of these. I know the people printing them are working faster than 24/7 to get these done. So you can do that. You can even buy special glasses. They're a little more expensive. They're not paper ones. There are even companies that make binoculars that have filters on them. But I want to emphasize, never use these glasses with binoculars together. That's actually very dangerous because, in fact, binoculars or telescopes will amplify the image of the sun, amplify the light, and will damage these glasses. Also, if the glasses slip off while you're looking through binoculars or a telescope, it's even more dangerous than just looking directly. So don't ever use these. You can only use binoculars that actually have filters built into them or specially designed filters. But the other way to look at it, because you probably don't want to stare up for 4 hours while the partial phase is going on, you're going to get tired of doing that. But you don't have to do that. You can actually use what we call indirect or projection methods. So any kind of pinhole will do. It will project a little small image of the sun. You'll see the crescent as the moon moves across it. I'm actually going to take a colander with me. I'm going to wear a colander, put it over, and it's going to make lots of cool images. You can get, we actually, ourselves and several other of our colleagues have produced postcards that have holes already put into them. You can project it with actually a mirror, a little small mirror, and an envelope. We've got this on our website, which I'll list the website later. But there's also the trees. The trees themselves, when the leaves cross, will make their own type of little pinholes, and you'll see these really cool shadows projected on the ground. The first time I saw that, it was really amazing. I looked down, and there are all these shadows, but all the shadows are like little crescents. It's a really, really cool effect. And you can actually you can take a box, like a cereal box. You close the edge, close all the parts of it. Inside, you can put a piece of white paper. On the other side, you make a big hole. You put a piece of tin foil, tape it over, poke a hole in that. And on the other side, you make a hole that you can look through. So you have the sun this way, and you would look down with the sun behind you, project through the pinhole into the box, and then you can look through and see it. So you can do that with larger boxes too. So there's a lot of different ways to do that. And there's a lot of great information on our website, which I'll show again, as well as colleagues like the AAS have a really fantastic website with all this information. So let's talk about eclipses in general. So why are, even though we have these issues with the orbit that makes it so the eclipses don't happen every month. We did some kind of eclipse every 6 months, but actually for total solar eclipses, we get, on average, a total solar eclipse somewhere in the world every 18 months. But the problem is the world is really big. So those eclipses are happening everywhere, but they're mostly happening over water or over places where there are not a lot of people. So that's the first reason that this eclipse is really special, because it's happening from coast to coast over the United States, okay, over the lower 48 states. A lot of people live there, and a lot of people are going to get to experience it. So that's one of the reasons that this is really exciting. It's happening over such a large piece of land that's populated, and it's going to basically be happening over an hour and a half. So in some ways, I'll talk a little bit more about this, but we're going to have not 2 minutes of observations, but an hour and a half of observations. Okay. Here's another perspective from a colleague who makes fantastic maps. This is just to show you, again, they're happening all over, but they're happening in places where there's just not a lot of people. So this particular eclipse also is pretty interesting for several reasons. Now, this is a collection of all the eclipses in the U.S. from 1776 to 2017. So a couple of features about this particular eclipse. This is the first coast-to-coast eclipse since 1918. Okay. This is the first total solar eclipse anywhere in the U.S. since 1991, but that was Hawaii. The previous one was 1979 in the northwestern part of the United States, over about, I think, 4 states. The next one that's going to happen in the United States is actually going to be in 2024. But one of the things that's interesting to add to what's kind of cool about this particular eclipse is the path for the one in August is going to, the one in 2024 is going to cross that. So in Carbondale, Illinois, the eclipse 7 years later is going to cross the one that's happening in August 21st. On average, eclipses happen at the same location on the globe every about 375 years. Okay. There's another one, 2045, that's going to cross the one in 2024, and it's going to cross it farther south. So this is pretty cool. The odds of this are pretty rare. So these are some of the reasons that make this particular eclipse pretty exciting. So here's zooming in on just the ones that are going to be happening over this year, 2024, and 2045, just to show you. So you can see where they cross each other. Okay. So that's a pretty rare and pretty exciting thing. Actually, I mentioned in Carbondale a lot. They like to call it the Crossroads of the eclipse. I was actually going to be in Carbondale, but now I'm not going to be in Carbondale. So I just got my plans changed on me. So, that's going to be pretty exciting for folks that will be there, because they'll get to see it again in just 7 years in the same place. So here's a summary of the path across the U.S. And we have maps at NASA on our website, which is eclipse2017.nasa.gov. And all of these maps are made along with lots of different visualizations like the one I showed you to give you tons of different perspectives of what's going on. And one of the things that's really cool about this is these maps were made using a lot of data from NASA. So that's one of the things that's sort of exciting, is that all the data that we're able to gather, we're using it to provide the most accurate results. I won't go into details because it's a talk unto itself, but I mentioned the fact that the shadow itself is not an ellipse or not a circle. And in fact, using the data, for example, from LRO, the Lunar Reconnaissance Orbiter, we've been able to provide the most accurate maps of the shape of the shadow as it moves across the country, as well as where the actual edge of totality is. Because the issue there is that even if you're right at the line where totality is, all you have to do is step right over and outside of it, and you're not in totality. Okay, so knowing where that line is, you're fine if you're in the center. But when you get close to the edge, the precision actually matters. Now, I will add just a little caveat. There are actually a lot of eclipse hunters who are interested in staying close to the edge because you see more structure and change, more of these Bailey's beads, as well as the diamond ring effect when you're close to the edge. So there, they really want to make sure that they know where they are. So a couple of things about the people that are going to see this eclipse. So this is a map showing you how many people live within 50, 100, up to 500 miles of the eclipse. So it turns out that majority of, depending on how fast you drive, I mean, I think I could probably drive 12 hours in a day. But even sort of an average driver, a good portion of the population lives within driving distance of the path of totality. So it's going to be a really interesting event. I'll just add that the reality is that we actually don't know how crazy it's really going to be. And it's something that people are very interested in finding out. And I've talked a lot to folks at DOT, the Department of Transportation. And we're very interested in seeing what's really going to happen when people try to get there. I can guarantee you that people who wake up the morning and go, there's eclipse today, and try to get there are out of luck. Probably the people who wake up the day before and try to get there are out of luck. And certainly depending on where you are. But there's going to be a lot of people who wake up and go, hey, I just heard there's a total solar eclipse. Let's go check it out. And it's 20 miles away, and they're not going to get there. So if you are planning on going, that's one thing to remember, something we try to emphasize again and again. Plan ahead. This is like Woodstock 200 times over, but across the whole country. Okay? So in terms of logistics, make sure that you have sunscreen. It's going to be August. It's going to be hot everywhere. Make sure you have water, food. But if you have an opportunity to go see this, take it. Because you will not be disappointed. If you're interested in going to see it, here's an average map. There are some more updated ones. NOAA just put out one. I've actually been trying to sort of sort through the results. But this is one from last year. This is an average map to show you the cloud cover. So you can see that, of course, basically west of the Mississippi, it gets better and better. Places like Eastern Oregon, Idaho, Wyoming, those are the best places. As you start to get over towards the East Coast, it starts to get a little bit more dicey in terms of the cloud cover. I'm actually now going to be in Charleston, South Carolina. So I grew up in the South. I know that at 2 and 3 o'clock, that's thunderstorm time. So we'll see. But it is close to the coast, and that does make a difference too. So real brief, I don't like to put a lot of words up, but just a couple of things. These are sort of the things that are really important to NASA. Now, why does NASA care? Well, first and foremost, one of the things that's very important to NASA is communicating science, communicating what we do. Because everything that we do at NASA is yours. Okay? We work for the country to explore the reaches of science, technology, our solar system and beyond, and so sharing that knowledge is paramount and part of the fundamental edict of NASA. But in terms of the eclipse, safety is first and foremost. Safety in terms of viewing and safety in terms of going to the events and making sure that you've really planned ahead. Science, I'm going to talk about that. Education, it is a huge education opportunity. I'm not going to focus so much on that, but that is something that folks that I work with have spent a lot of time thinking about. This has been a really interesting challenge to both, how do we reach and take this as an opportunity to talk about, orbits and the sun, the moon, the whole sun-Earth-moon system, and even the Earth, because one of the things I'll touch on briefly is that this is actually a unique opportunity to do Earth science, not just sun, Earth, not just sun and moon, but actually Earth. There's some unique opportunities which I'll talk about. So these are some of the science that we're interested in. Of course, there's the sun. There's observing it from the ground, observing from Earth, studying the moon. Actually, in this case, LRO is going to have the advantage of looking at the shadow from the moon. And that's a really, really amazing opportunity. This is a way to connect to other types of science that we do, not necessarily directly, but eclipse is a special type of what we call a transit, where one object moves in front of another one. A planet moves in front of a star, or a moon moves in front of another planet. Within our solar system, using transits and eclipses is a very important way in which we study those objects. And beyond that, it's in a critical way that we study things like exoplanets. And that's actually how we found exoplanets, is by transits. Okay. Now, I'll add one thing here. I'll talk a little bit more about some of the earth science, but actually something I just found out a couple of weeks ago. Actually, my colleague in the audience came up with a brilliant idea. We're going to be flying balloons around the country. I think it's 57. So 57 high altitude balloons. And these balloons are going to go in a range of 60 to 80,000 feet. So that's generally to look down at the Earth, to look at the shadow, to see the change in environment. But that's about the pressure, it's equivalent to basically the atmosphere that you experience on Mars. Okay, so what the idea was is you take these little packets that have bacteria, and I apologize if I don't say it exactly right, but put these little packets with bacteria and then actually send them up in the balloons to study what happens. Because ultimately, we want to know, is there life? Are there are there the components of life, or is there even life in this solar system beyond Earth, or even beyond our solar system? So one of the places that it's critical to study this is Mars. So this is an opportunity to actually connect with our neighbor planet and study the environment. So I think it's really cool, and it's what we call a mission of opportunity, or an experiment of opportunity, where we added something on to something that was already happening. Okay. But I'm going to focus for a short bit on the sun. This actually happens to be my area of study. I'm a solar physicist, and the eclipse, as I mentioned, is an opportunity to really study a unique and critical part of the sun's atmosphere, the corona. Okay, so I showed you those images of the sun. They weren't too exciting, except for the eclipse image. But you know what? If we step out into space, okay, we step outside of our atmosphere. Right now, we see the sun from the ground in a very narrow region, a narrow band of light, mostly visible light, a little bit of UV, infrared, but it's a small portion of the entire electromagnetic spectrum. Light goes from microwaves and radio waves all the way to X-rays and gamma rays, and it's huge changes in the amount of energy and the characteristics of that light, and that tells you lots of different things depending on which kind of light you're looking at. But when we go out into space and we look at the sun, we see something very different. This is the sun that we see. Can we turn these lights down a little bit? We can't? Okay. Well, what you're seeing here is the sun in extreme ultraviolet, and hopefully you can see. I have this dying urge to run over to this image and touch it, but you see all this activity happening, okay? You're seeing huge explosions. You see that flash of light? That's called a solar flare. That is, enough energy is released in that flash of light over a period of a few minutes to hours to power the entire world for 100,000 years. Okay? But not only do you have that flash of light, the sun is also expelling huge blobs of itself. And magnetic field and solar material are flying off into space at millions of miles an hour. And all of this stuff, all this energy and material is filling and bathing the entire solar system. And it creates an entire environment as all this stuff coming off the sun interacts with the planets, with comets, with asteroids, with everything in our solar system. Here's another example from the same spacecraft. So you're seeing these huge eruptions, many, many times the size of the Earth. Okay, that thing, when it gets to its farthest expanse, it's about 15 Earths from the edge of the sun to the top of it. Okay, and that's billions of tons of solar material that are flying off. So this area, all of this action that you see, all this stuff happening on the sun, happens in the corona. It happens in this region of the sun that we see during a total solar eclipse. Okay, and I won't go into all the details, but basically what's happening is the sun is a giant ball of electrified gas. And inside of it, it has magnetic fields. These are the same magnetic fields that make a magnet stick to your refrigerator, okay? But these are huge and much, much stronger. But these magnetic fields are kind of like little rubber bands, except they're really, really big rubber bands. And when you twist them and twist them and twist them, if you take a rubber band and you twist it and twist it and twist it, eventually it'll start to knot up. And at some point, you're going to twist it enough, it's going to pop. And when it pops, it actually releases energy. The same thing happens with magnetic fields. They have a similar property. They get all twisted and they release that energy, and that's what's creating that solar flare and that big blob of stuff flying off the sun. And so all that structure that you saw in those images of the corona, that's actually magnetic field. They're invisible, but the corona itself actually highlights them. You can see them. And understanding what's happening there is telling us why this is happening and helping us to understand not only why it's happening, but how do we predict this. The ultimate reason is because all of this stuff is interacting with all of the planets, and it's part of the fundamental environment that we have to understand. But also, this stuff is electromagnetic. Okay, it responds to electricity and magnetism. And what in our society responds to electricity and magnetism? Technology. And so we have satellites in space, we have GPS, we have communication systems, we even have power grids on the ground. All of them interact with this stuff that comes off the sun. And sometimes these explosions can be large enough that it actually can knock out our communications. It can disable spacecraft. It actually creates an incredibly harsh environment in space for astronauts. So we need to understand that environment, not only around the Earth, but traveling to places like Mars. Understanding this environment is critical. And in the worst case scenario, we have seen in the past when power grids went down because of these solar eruptions. So these are all the reasons why we have to understand it. So we can make artificial eclipses in space, and you can see this material coming off. But the problem is, you see that circle, that's actually where the sun is. Because even though we can make these eclipses in space, we can't do as good a job as the moon does with the Earth and the sun. This is the eclipse I showed you, and that area from the black disk out to that white line is that area outside of this white disk that we don't see. So you're seeing that from the ground, we see this whole area, actually the most important region for space weather and solar activity. We only see this in visible light from the ground. So what that means is we have a unique opportunity to see the eclipse and see what's happening on the sun in a way that we normally couldn't see, even with the most sophisticated spacecraft. Now, back to what makes this eclipse special. Normally, an eclipse at any one location is only 2 minutes or so. But think of this like having a camera following a player down a football field or a soccer field. You have a string, the camera follows it, and you can see the action all the way. Well, we can't quite do that because we can't follow the shadow that's moving at 1,500 miles per hour. But we can line up lots of cameras along the path, lots of telescopes, and even lots of balloons to study as this thing moves along. We can put all that data together, and now instead of having a 2-minute observation, we have an 1.5-hour observation. And we can finally see things that are happening here. Now, there are lots of other things that are exciting. One of the things we're going to do is we're testing technology on the ground that we'll eventually put into space. That's an important thing because you want to test things before you fly them. So that's another opportunity. And I'm glossing over the details, but the other part is the Earth part. So the eclipse itself, when that shadow is moving across the country, where it hits, it gets dark, about as dark as a moonlit night. The temperature drops 5, 10 more degrees. The winds change. Animals become quiet or freaked out. this whole eerie structure. You look around, you're sitting inside this shadow, and every direction is dusk all the way around. So it creates a really amazing local environment, and that local environment moves across the country. So that's one of the things we're doing, is we're actually looking at how the environment, how the climate, how the animals, how the plants, how everything reacts as it's moving across the country. And because it's going over such a huge piece of land, we can study many different little mini environments all together. So that's kind of the Earth perspective. So we're doing huge amounts of science, looking at the shadow from the moon, looking at the corona from the ground, looking at the Earth, seeing how it changes both down on the ground and even from balloons above. And even spacecraft are looking down. Earth observing spacecraft are following this. So this is an opportunity to bring together all of these different ground-based observations, space-based observations, and get a holistic big picture. Not just one snapshot here or there, but to see all of what's happening from all these different vantage points. And that's really where NASA is bringing in all the things that it has to offer. It's bringing in all of these different assets and helping to bring them all together, working with many different partners from different government agencies, universities, private industry. All of these are coming together to bring all of this science for this unique opportunity. So let me wrap up with, this is actually a map, and this map actually is now out of date. It changes so quickly, but this is just showing you NASA along the path is going to have NASA TV crews that'll be taping at local places where they'll be observing the eclipse, having activities. We're going to have observations from aircraft starting at the beginning of the eclipse. We have a boat from the Coast Guard at the end of the eclipse that'll be launching a balloon. We also have lots of educational activities along the path and recording with many different people. So all of this will be brought together in a big broadcast from NASA TV. And then NASA TV will also be bringing in through nasa.gov lots of webcasts from all these different locations. It includes webcasts from every one of those 57 balloons. So what's going to be seen from all those balloons at 80,000 feet will be broadcast live down to the NASA website. So to find out more, you can go to the NASA website. Actually, hold on, it's telling me to connect to the Wi-Fi here. So eclipse2017.nasa.gov. I'll also add that next week on Wednesday, the 21st of June, is a news press conference from the museum that'll be broadcast by NASA TV. We'll have partners from NOAA, from the National Park Service. I didn't add that actually some of those sites you see are actually Park Service sites. We'll have members of some other agencies there, as well as many different experts from around NASA to talk to the press, to tell everybody about what's going on. This has been a huge opportunity. If you go to this website, you can find maps, Google Maps, with links to all of the different activities that are happening across the country. We have groups, for example, there are 1,500 libraries that are connected through one of our partners. And there's also lots of educational materials as well as maps. All of the materials that you can get today is on the site and downloadable for free. And then you can find out what's going on and any changes that are happening for the event. So lastly, be safe, plan ahead, and have fun. Enjoy and watch the show. And if you can't be in the path of totality, there's going to be so much coming out from NASA, from our colleagues at places like the Exploratorium, that hopefully you'll get to experience it, and it's just going to want to make you go to the 2024 eclipse.
those who don't have to run off, I guess we could take a couple questions, and if you would repeat the questions.
Yes, ma'am.
You mentioned being concerned about binoculars. What concerns about photographs or different photography?
Well, as long as you're not looking through, but I mean, you want to. There's a lot of information out there about how to do it correctly in terms of digital photography. Colleagues like Fred Espenak and others have books and websites on how to do it. You're going to want to use filters, for example, during the partial phase, because you're not going to see anything but a big bright, a bright image. But there are lots of different things you can do. You can do projection methods and all this. So there are many different options for doing photography. Now, the one thing I'm going to add, and this is something that all the eclipse experts have said to me time and time again, unless you're really, really set on doing photography, there's going to be some amazing photography. And if this is the first eclipse you've ever seen, don't waste your time doing photography. It's 2 minutes, maybe less, maybe a little bit more. Put your camera down, look up and enjoy it. And enjoy what's happening around you, because there will be other opportunities.
So, out of studying the sun and eclipses and ancient history, what's your favorite reference in ancient history referring to the solar?
Oh, gosh. I don't know. There's a lot of really cool myths. I always like, there's one about, I guess a lot of the myths are about different animals that are eating the moon. There's some really cool stories. And actually what I liked most was seeing how stories from India traveled through different cultures and evolved and actually get to Siberia. So you can actually see how the different stories evolved for the cultures, but they're all the same story. So I think that's actually one of the things I like the most, and the Vietnamese frog that eats the eclipse. I like the frog. So, but I think that's one of the coolest things. There's a lot of really great stories, though. Yes, sir.
1919, Eddington. Was that a solar or lunar eclipse?
It was a solar eclipse. Yeah. So referring to Eddington looking at the eclipse in the 1900s, it was actually one of the first verifications of general theory of relativity. So it's actually really great because we're down at the 100-year anniversary of general relativity. So he looked at both the apparent location of a star versus its actual location because of the bending of light by gravity of the sun. So it's a really, really neat experiment that he did.
Somebody else.
Yeah, let me make sure to get somebody else first. Go ahead.
You said we couldn't filter the sun out as well as the moon does it. Why is that? Why can't we do it in space or on the ground with a telescope?
Well, it's optical issues with diffraction of light. I mean, when you put the disk to block out the sun, the closer the disk is to the camera, you're going to get diffraction around the edge of it. And with the moon, Earth, sun system, the distances are so huge, you don't get the diffraction issues. So it's just a geometric optics problem, basically. Now we're looking at how to make spacecraft with large separations. That's certainly been done in other places like X-rays, where you need to have long distances. So I think that's something that might happen in the future, more than likely will, and we'll just see how good we do.
Show them your shoes.
Oh, so
His solar flare shoes.
These are my shoes. So you have a question over here.
How frequently do solar flares happen?
Solar flares? Oh, okay, that's a great question. So, well, it's kind of a statistical thing. So, but they follow an activity cycle. So just like we have hurricane cycles of roughly a year, and we have a peak during the end of the summer, beginning of the fall. The sun has a cycle of going from low, high to low of roughly 11 years. Okay, sometimes a little shorter, sometimes a little longer. So we have solar flares all the time, but as you get closer to the peak, you get more and larger ones. What's that? Yeah, we're getting close to the bottom right now. The peak was around 2013, and actually there are actually two humps. There's actually two peaks. The north and south part of the sun have different peaks, but we're getting close to solar minimum right now. It's kind of unfortunate, but there are different things. The structure of the corona changes during the solar cycle. And so that's actually a really interesting thing. So even if we don't have a lot of activity and we don't see, let's say, an eruption happening during the eclipse, seeing the structure of the corona change from the solar physicist point of view is really, really important. And actually, some things we've seen is it's different than we've expected, actually. Did you have another question? Or?
Does that mean the 2024 will be close to the
Yes. And that's the cool thing. I mean, I'm glad you brought that up, because that means we have two eclipses very close, long period of observation, and we can see two different parts of the solar cycle. So that's a fantastic question. I'm glad you brought that up. Yes, sir.
So many questions. I just read a report stating that most stars come into existence with a twin, come in pairs. Stars come into existence as a pair. Does our sun have a twin, and where is it?
Not as far as we know. I mean, it is the case that they're generally more binaries. Now, actually, I had somebody tell me this morning that there's some sort of story going around about this. I haven't checked it out. So, but we do not have a twin star.
Okay, and if you do find it, you will put it up on the website.
Oh, we certainly will. We certainly will.
Okay.
Yes, ma'am.
How will cloud cover affect viewing? So we don't have this.
Well, so that's a good question. So how will cloud cover affect viewing? Now, it will affect viewing. I mean, you will not see, maybe you may not see the actual eclipse, but you're going to see the light levels change. The animals are still going to respond. The temperature is still going to change. The environment is still going to change. So even if you don't see the eclipse itself, and I have a huge risk of that happening where I'm going to be, you still get to experience the whole event. So don't worry, you're still going to get something spectacular from it. Yes, sir.
Do scientists know why it's every 11 years or 8 years or 9, or why is the cycle?
That's a really great question. The simple answer is no. We actually know, well, we think we know the process inside the sun. It's called a dynamo, okay, which is a process of how we actually think the magnetic fields are generated inside things like planets, like the Earth. A liquid core, sort of similar. When liquids that are conducting spin, they create magnetic fields. We're pretty sure that's happening inside the sun, but we don't completely understand the physics, and we can create a dynamo, but we can't get it to give us the right number, 11 years or 8 years. And we know it changes. We see other stars that have cycles that are different. But right now, we can't get it to be exactly 11 years, so we don't really have a self-consistent theory. Yes, ma'am.
You mentioned about animals being affected by the eclipse. What happens? What do they do? And is it better if the animal is sensitive not to have them experience the eclipse?
I don't think there's any, I mean, I'm not an expert on this. I don't think there's anything dangerous about it for animals. Basically, I mean, you can imagine if you're sitting somewhere and all of a sudden it gets dark real quick and you have no idea why, and all of a sudden the temperature changes and it feels like nighttime, you're going to react to that. And in the simplest terms, the animals are responding to, they're all of a sudden in nighttime very quickly. And so that's probably a little bit disturbing for it to happen so quickly, but it's also, they're just responding to a totally different environment, something that they think it's nighttime. But I don't think there's anything dangerous. I mean, I'm not going to hide my cats or anything like that. So, yes, sir.
I saw that happen in 1970.
Oh, cool.
And it was very strange. The birds were just all of a sudden heading for the trees.
I mean, there's a lot of really great stories. There's actually on our website, on the Eclipse website, we have a video from a colleague, Doug Duncan, who's seen a lot of eclipses. And he's got a really nice video about different animal experiences. He told me a story of once he was on a ship, and when the totality hit, whales and dolphins surfaced and just looked up and didn't do anything during totality, and then as soon as it was over, they went back to their business. He said it was pretty eerie.
They had their little glasses on.
Yeah.
Right?
Yes, ma'am.
Talk about shadow bands.
I don't know a lot about shadow bands, unfortunately. I can certainly, I've got some great books and some great colleagues I can point you to, but unfortunately, I don't really know a lot. Do you know anything about shadow bands, Jim? Yeah, I don't know anything about shadow bands. Shadow bands is this really cool striation effect that you see during eclipses, and it's not just total eclipses. You can see shadow bands, I think, during annular eclipses too, but I'll be honest, I don't really know a lot about it. But I've actually got some books with me right here that I brought. One from Fred Espenek, which is really good, and he would know. He's really cool, and it would be the kind of person that you could just send him an email and ask him. So, sorry, I can't tell you more.
I think we'd better close this down.
Let me answer one more question.
Is there going to be any major ocean tide impact?
I don't think so. I mean, it's not going to be over the ocean, first of all, that long. But I can't imagine. I'll be honest, I'm not an expert on that, but I really can't imagine that there would be any reason that there'd be any sort of change like that. I'm sure there would be tiny, tiny changes, but probably things we wouldn't be able to easily measure. Yeah. So, all right, one more question.
Any advice on a place that's not too crowded that's likely to have
Oh, gosh. Well, definitely stay away from Oregon. Maybe Idaho or Wyoming.
Oh, no. I've heard lots of people.
Yeah, I don't know that there really is a. I mean, I don't know. I think the most determining factor should be, do you have a place to stay that's within your budget? Because a lot of places are really, really gouging people. It's actually been so bad of an issue in Oregon that the governor got involved. Now, strangely enough, I was talking to a colleague in South Carolina, and we were looking online, and there are a lot of places available in South Carolina. Now, South Carolina is going to be really populated. But if you can get it, I mean, frankly, if you could get a hotel near the center of the path of totality, I would just go there and then step outside your hotel room and see it, you know. Don't worry about all the frill, and because there's a lot of towns that have activities and events and things like that. But if you can make sure you can get there and you can afford the hotel, then go wherever you can go. So the best thing to do is to be as close as you can to where you want to observe. Because then you don't have to worry about traffic and all that kind of stuff.
What about airplanes?
Airplanes, actually I have a colleague, Mike Kincheronakis. You may be familiar, there was a video that came out during the 2016 eclipse, which was predominantly in Micronesia. He was able to, because he used to work for CBS and had some pull, he was able to convince Alaskan Airlines to change the path of their airplane. And so they flew the plane through the path of totality, and he made a video of it. And he's famous for being the oh my God guy, because he said oh my God about 22 times, I think. And it was picked up by CBS, became a sort of a viral video. He's a huge avid eclipse chaser. He's been seeing eclipses when he was a kid. He went to the '79 eclipse. So you can find ones that are in the path. It's not necessarily easy. I will say, if you're truly interested in that, my colleague Sten Odenwall, who's amazing with numbers, and he sat down and figured out all the airplanes that were going to probably be in the path of totality. So he's got a spreadsheet of that, you know. It looks really cool. The video was amazing. Now, of course, you won't experience the environmental issues, but they were above the clouds, and you could see the shadow coming in a way that I've not seen in any other video, because you don't have any of the terrain to worry about. So it was pretty spectacular. So I actually looked into trying to get on one of the NASA planes, but all the high uppies are the ones that get to be on the NASA plane. So I tried to see, I couldn't carry luggage or anything like that to do it. But it's worth a try, yeah.
One more?
One more, okay.
What are the special glasses made of?
They're just made of a particular type of plastic. I don't know the details. I will say the thing to note, there's an ISO standard. So the back of the glasses should say ISO, and I don't remember the exact number, but it should have ISO standard on it. Older ones will have CE. That's a European standard. It's still acceptable. But currently, the ISO standard is the international standard. So if you go to our website, we have a joint safety bulletin with the AAS, NSF, and the American Optometrist and Ophthalmology Societies. We list the 4 major producers that we know. They're not the only ones, but they're the ones we know are ISO certified. And you can go to those. They sell all kinds of glasses. And then places like Lunt, L-U-N-T, are one of the people that I know. They sell... They're not the only people, but they sell the binoculars that actually have the built-in filters, and they're like $25 or something. They're not that expensive. So there's a lot of really cool options out there. So thanks a lot, everybody. I really appreciate it. Thanks for waiting for me. So
This has been a presentation of the Library of Congress. Visit us at loc.gov.